So guys, welcome back to another video of TRYHACKME beginner's path. In last video we solved the Linux fundamentals part 1, part 2 and part 3. So in this video we will proceed with the networking section of TRYHACKME. So as I was on my Windows operating system, I just completed the 4 tasks, but I'm gonna show you what are the solution of this, as this is also a write-up or a walkthrough video. So as you can see in the first task, it's saying what is the aim of this room and what we are going to learn. It says we are going to learn about OSI model, TCP/IP model, how this model looks in practice, and some basic introduction to the networking tool. So task 1 was nothing, just clicked on completed and it was done. For the task 2, it gave us an introduction about application layer, presentation layer, session layer, transport, network, data link and physical layer. These are the 7 layers of the OSI model which works in networking in the modern time. You can just read this and become familiar what this layer are capable of and what are the main functionality of this. So the questions were, which layer would you choose to send data over TCP or UDP? So as you can see, the transport layer serves numerous important functions. The two most common protocols in the transport layer are TCP and UDP, that is transmission control protocol and user datagram protocol. The second was, which layer checks receives packet to make sure that they haven't been corrupted, means they were not captured in between and changed some parameters, or it was malfunction, something like that. So the data link layer does that, as it is also capable of transferring the layer to the unique MAC or from the system it were transferred from or requested from. So the third is, in which layer would data be formatted in preparation for transmission? So the second layer is capable of doing that too. As you can see, additionally, it is also the job of data link layer to present the data in the format suitable for transmission. It's something like modem for demodulation and modulation. The next one is, in which layer transmits and receives data? That's the physical layer. This is the very first layer that we come in contact with. Sorry, not us, but the systems. Now, which layer encrypts, compress, or otherwise transform the initial data to give it a standard format? So that's the sixth layer, named presentation layer. You can read about this here. Now, which layer tracks communication between the host and receiving computer? So the layer 5, the data session layer, checks for that. Which layer accepts communication request from application? The first most in the OSI model and the last most from our end, that is the 7th layer as application layer. So which layer handles logical addressing? That's our network layer. You can see addressing of IPv4 format or IPv6. When sending data over TCP, what would you call the byte-sized pieces of packet? So the byte-sized packets are known as segments when it is transmitted over TCP, and when it is transferred over UDP, it is known as datagrams. So now it says we have to do some research, like which layer would the FTP protocol communicate with? So it should be the very first layer which comes in the networking section, that is the 7th one, application layer. You can just do Google and you will get that. Let me show you. So you see, it's just application layer. Now, which transport layer would be best suited to transmit a live video? That is the UDP, as when we transfer packets over TCP, it would take some time for that, and the video may get lagged. So for live transmission, we use UDP as it is fast mode. Now the task 3 was encapsulation. states that what are the packets named in every stage. Like in stage 7, it is known as bits. Stage 6, frames. 5, packets. In stage 4, it is segments or datagrams. Segments for TCP or datagrams for UDP. Step 3, that is session layer, it is known as data. In presentation layer, it is also known as data. In application layer, also it is known as data. So the last 3 or the first 3, that is the session layer, presentation layer, and application layer, the data packets are known as data itself. You can just read this for further information. So it states what is de-encapsulation. It is about adding some information or stripping of the added information to make it in readable format. You should be knowing, like, when data is encrypted, some another hashing methods or some extra text are added to the lines to make it secure, that if the data packets are captured in between using man in the middle attack, the attacker or hacker can't recognize what's in that packet. So the question is, how do you refer to data at layer 2 of encapsulation process with the OSI model? So for the second one, it's known as frames in the data link layer. Here trailer are added, as I said, for encryption method. How do you refer to a data at layer 4 of encapsulation process with the OSI model if the UDP protocol has been selected? So as I told in a previous one, TCP is I forgot the name. TCP is segments, and for UDP it is datagrams. So what process would a computer perform on a received message? So it's a de-encapsulation, means removing the extra text and making it in readable format, and when we send or transmit a message, it is known as encapsulation. Now, which is the only layer of OSI model to add a trailer during encapsulation? As I told, data link header and trailer are added, means data link layer is capable. Now, does encapsulation provide an extra layer of security? Yes. As I told, it prevents from the user data leakage while in the middle attack and makes it secure from the hacker. So now let's go to our task 4. So it says like TCP IP model. The main TCP IP model contains application layer, transport layer, internet layer, and network interface. These are the 4 layers, whereas in OSI it has 7 layers. So all OSI models are equivalent to TCP IP in some extent. So as you can see, it's shared to client by SIN, that is synchronizing, and ACK stands for acknowledgement. You can just read about this. The history is here, why the TCP IP or OSI model were originally created. So now the first question is, which model was introduced first, OSI or TCP IP? So the TCP IP is much more older than OSI. If you have some basic ideas of networking, you may be knowing this. Now, which layer of TCP IP model covers the functionality of the transport layer of the OSI model? So it says transport layer of the OSI model. So as you can see in this chart, transport layer of OSI model is also known as transport layer of TCP IP model. So which layer of the TCP IP model covers the functionality of session layer of OSI model? So session layer of OSI model is the equivalent to the application layer of TCP IP model. Now the network interface layer of the TCP IP model covers the functionality of 2 layers in the OSI model. These layers are data link and. So it's asking about the second layer. So it's a data link, and the physical layer are referred to as network interface in the TCP IP model. So it's just physical. So which layer of TCP/IP model handles the functionality of the OSI network layer? It is the internet section. You can just refer above. Now, what kind of protocol is TCP? That is connection based, whereas UDP is connectionless. What is SYN short for? As I told, it's synchronized. What is the second step of the three-way handshake? The three-way handshake, as you can see here, this is the method. So the second one is SYN and ACK both. And what is the short name for acknowledgement? It's ACK. So that's it for the task 5. Now we will just move with the task. Sorry, that's it for with task 4. Now we will move to the task 5 section of the networking. I did all this one in the Windows machine, but I needed the manual, so I just came to Kali and just making this video for you all. And if you haven't subscribed to my channel, just do that. And don't forget to press the bell icon for more videos that I'm gonna make on TRYHACKME and further with Hack the Box and OneNow. So it's about ping. We mainly do ping to check whether the servers are up or not, whether it's responding or capturing our packet, or the data packets are getting lost if the server is dead. So we can use terminal, or in Windows you can use the command prompt. I just open this and we will run the command as ping google.com. As you can see, 64 byte from my router was sent to the Google servers and it was received. So I will just cancel this for now and just clear this. So now it's asked what command would you use to ping the bbc.co.uk website. So it's simple. We will write ping, that is the package we are going to use, space followed by the IP or the domain name. Now it says ping whatever be the name, oracle.co.uk. I will do it in front of you. I will do ping I guess I wrote the name correctly. Just ping it. So as you can see, we were given the IP of the servers to where the requests are being sent. We'll just cancel this by pressing Ctrl C. So now it's asking what switch lets you change the interval of set ping request. So means after how many interval the another ping packet will be sent to the server for checking. For that we will do man ping. So I'm just gonna find out what does that. I know the solution. It's -I to set the interval, wait interval second between sending each packet. Minus small I. As I told in the previous video, the small one and the capital one are different, so these are case sensitive and do pay attention. Like here, as you can see, the -I says about the interface, either an address, interface name, or a VRF name. Now what switch would allow you to restrict request to IPv4? That is the 32-bit, I guess. So I know the answer. That is -4. You can scroll up and says -4 for use IPv4 only and -6 for use IPv6 only. So now it's asking what switch would you give a more verbose output. So for that, let's check. Should be V, I guess, for verbose. No, it's not that. So yeah, as you can see, -V verbose output do not suppress dup replies when pinging multicast addresses. So -V exactly. So this was it in the ping. So as I told you, the main function of the ping is to check whether this server or the machines is up or not. Now we'll just go to our next section, that is traceroute section. So in this we have 4 problems. We'll just solve these. So it says the logical follow of command to the ping command is traceroute. Traceroute can be used to map the path your request takes as it heads to the target machine. So it's similar like ping, not similar but upgraded version of ping. Like in ping, it's directly send the packets from our computer to the server, and we don't know from which IPs or system it is hopping from. When we use TRYHACKME, that is in Windows, and traceroute on Linux. Here you can see that TRYHACKME is for Windows and traceroute is for Linux. So in this we know from which IPs our packet is jumping or hopping before reaching our final destination target, and whether the packets are lost in between or just the servers or the target machine are down. So you can do as man traceroute for more, and you can see that 13 hops to get from my router underscore gateway to the Google server at 216.58205.46. For now I can show you that too. Let's just quit this and do traceroute google.com. So as you can see, it needed 30 hops max, but it just went in 2 hops to the server. I'll just clear this. And so the questions are used. Traceroute on tryhackme.com. Can you see the path of the request taken? So let's just do that. Traceroute tryhackme.com. Again too, I guess I'm into some issue, or like if you want I can just do it in Windows also to show you how it works. Just open the command prompt using CMD, or you can also use PowerShell. Just write PowerShell. PowerShell. This will be by default in further systems like Windows 11, 12 and furthermore. For now I will use the old one, that is CMD. So now let's use the command traceRT. I can't zoom in, so nothing to worry about. TRYHACKME, tryhackme.com. So it's the first IP it jumped upon. Second, if you are thinking that's my IP, then you are wrong. I am always under a VPN service, so don't try to just bypass that or attack me. That won't give you anything. It will take some time to hop from all the machines to get to the server. You can just check it. I will just stop it for now and exit this. So yes, we see the path of our request. So now it's asking what switch would you use to specify an interface when using traceroute. So for interface, as you can see, it is clear by name only, that is I. So for the interface, the flag is -I. Let's just submit it. Now what switch would you use if you wanted to use TCP SYN request when tracing the route? So let's just check for that. TCP while tracing the route. So here it says TCP. So SYN here. So there is a couple of options for TCP method: SYN, ACK, and furthermore. So the answer should be -T. That's correct. Now lateral thinking means we have to think out of the box. Now, which layer of TCP/IP model will traceroute run on by default? Which layer of TCP/IP model will traceroute run on by? Oh, means what will be the path or what will be the method used when it runs without any flag, means by default. So it will be on internet. Yes, that's correct. Now we will move to the task 7, that is who is. So it is like we do a domain name checkup, whom did it belong to or what, when it was purchased on, where it was registered, for how much time it is registered, means expiry date, as you can see here, the bbc.co.uk, date validation, registrar, British Broadcasting Corporation, URL is this, relevant date registered on before August 1996, expiry date 13 December 2025, last updated 29 October 2016. Means it was about to expire in a few years, so it was again renewed on 29th of October 2016. So registration status registered until expiry date, means this is not expired yet. These are the name servers, these are the IPs, IPv4 and IPv6. And this one shows when was who is lookup made, so the date and time. Now let's proceed with the problems. And one more thing to be noted, that according to this we have to install who is on our systems, as it is not pre-installed, so we will just run the command. First of it, run sudo apt update, give the password for a Kali for admin access, that is sudo super user. Will take few time. I will just pause the video for now. It's not going to be finished. I'm sorry, I just scrolled it. So now it gives us a command type upgradable. We won't do that. We will just run the command apt install. I'm sorry. Who is? Sorry, I didn't get sudo apt install who is. So it's already up to date. So now perform a search on facebook.com. Who is search on facebook.com. So let's just do that. Who is facebook.com. So it gets us the directory, the admin city, state, the tech country, postal address, name, servers, and many other information regarding that domain name. So now it's asked what is the registrant postal code for facebook.com. So let's just search for that postal code. It should be down here. So admin postal code is 94025. When was the facebook.com first registered? So it should be above. First registered. That's 29/03/1997. 29/03/1997. Now perform who is on Microsoft.com. Let's just do that. Who is Microsoft.com. Completed. Now the first question is, which city is a registrant based in? So let's see. So the registrant city is Redmond. Now this is some OSINT, means we have to search on Google and find out. So it's asked what is the name of the golf course that is near the registrant address for Microsoft.com. So registrant address, that is Redmond Street, is 1 Microsoft way. So we'll just do it's asked for golf course. So golf course near Redmond, what was that city? So let's find out which is the nearest one. Let's just try with this one first. It is 3-star rated and I guess nearer. As you can see, number 2 is very much near to Redmond. Let's check it, hit and try. Yes, it is correct. Oh sorry, we will have completed to this also. Now what is the registered tech email for Microsoft? Let's just check for registered tech email. I'm sorry, I just came down. So registered tech email should be over here. So now for that's it in the task 7. Who is, you can just do another who is on google.com or today.com and further. You can do this on any domain. If you want, you can do that too on TRYHACKME also. Like who is, now we'll run who is TRYHACKME.com. So we got the details like it was technically from, what's this? I never heard of this. Tech email is something like more secure, white held for privacy. See, it's extra secure, I guess. It's some kind of hash. Let's just decode it for, let's see what's in it. You just go to CyberChef, the most favorite website for all hash decryptors and hackers. Paste it here. We'll just grab the magic one, drop it here. Can't be decoded, means maybe this is the website or something like that, so leave it. So that was it in the task 7. I will just clear the terminal for now. Now let's move to our task 8, that is networking tool. So we now earlier talked about how we searched about the domain names. Now we'll check how that works. So even wonder how a URL gets converted into an IP address that your computer can understand? The answer is a TCP IP protocol called DNS, that is domain name system. You can just read it. It says something difference about the .com and .co.uk. Now when you visit a website in a browser, this all happens automatically, but we can also do it manually with a tool called dig. Like ping and traceroute, dig can be installed automatically on Linux systems. Dig allows us to manually query recursive DNS servers of our choice for information about domains. So we do dig with domain at the DNS server IP, like dig google.com at 1.1.1. I guess the 1.1.1 is some sort of VPN service. So it gives us many more information about the DNS record, time to live. So what is DNS short for? It's domain name system. I just typed it when I was on Windows. So it says what is the first type of DNS server your computer would query when you search for a domain. So as we read earlier, it should be recursive. Let me just show it to you. I will just do Control F. It's not working. Sorry. Control F, recursive. As you can see, your computer will then send a request to what's known as recursive DNS server. Just exit this, and the solution will be recursive. This is done. So now the next question is, what type of DNS server contains records specific to domain extensions, that is .com, .co, UK, etc. Use the long version of the name. I know that's a top level domain. You can just find it here. It should be here. Top level domain. TLD servers are split up into extensions. You can just read more about that on Google. So let's just write that top level colon domain. So now where is the very first place your computer would look to find the IP address of a domain? That is local cache. You can find this also in the above paragraph if you don't know about this. Now Google runs two public DNS servers. One of them can be queried with the IP 8.8.8.8. What is the IP of the other one? So you can just it's asking for doing a research, so we'll just write IP of Google DNS servers. So it's 8.8.8 and another one is 8.8.4.4. Let's do that 8.8.4.4. If a DNS query has a TTL of 24 hours, what number would the DIC query show? So let's just check how to do that. The store in its local cache, the TTL record tells your computer when to stop considering the record as being valid. When it should request the data again rather than relying on the cached copy. For DNA. For now I know the answer, but let me just show you how you can just figure that out. So it shows what to do. TLS of 24 hours, that is 16 to 16 to 24, that is 86400 seconds. That is correct. Now we successfully completed our task 8, that is dig. Now on further reading, it says that we have a Cisco self-study guide by Steve McQuarrie. You can just go and read that book. And basically it is designed to as a study guide for CCNA exam. That book serves equally well as a very rounded introduction to networking principles. You can just do that. And for now we just finished our introductory networking room of beginners challenge. If you just like the walkthrough or the commands I run, just don't forget to subscribe the channel and share with your friends. So see you in the next video. Till then, stay safe and happy. Thank you.